So thank you very much, Emanuela and Caroline. Please confirm I can be heard and you can see my screen.
Yes, we can see and hear you. Thank you so much.
Okay. So hello, everyone. It's nice to be here. We'll walk through the paper, A Mathematical Model for the Dynamics and Control of Malaria in Nigeria by Collins and Duffy. So by way of introduction, malaria is a significant public health problem caused by Plasmodium parasites that are transmitted to humans through the bites of infected female Anopheles mosquito. Malaria is endemic in 85 countries of the world, and these are mostly the tropical countries. The majority of the cases and deaths are found in sub-Saharan Africa, and Nigeria is one of the countries that is hardest hit with 67 million cases and about 193,000 deaths in 2022. So globally, in recent times, there have been increasing reports of treatment failure, and this has been a major obstacle in the journey towards malaria elimination globally. And treatment failure could be caused by non-compliance to the dosage regimen and also suboptimal dosages. Drug resistance is also a known cause of treatment failure. However, the existing mathematical models do not fully incorporate drug resistance and control measures, including this use of nets, as well as they do not use the real data of Nigeria. So this is the gap that the authors were looking to fill via this study. So these are the research questions. They include, how does malaria spread and persist in Nigeria, considering factors like drug resistance and treatment? Then what is the effect of treatment rates of the resistant strain and the sensitive strain on the dynamics of malaria in Nigeria? The third one, what is the effect of treatment failure of the resistant strain and the sensitive strain on the dynamics of malaria in Nigeria? Next, what is the effect of mosquito nets use among individuals infected with the resistant strain and the sensitive strain on the dynamics of malaria in Nigeria? Lastly, what are the possible future dynamics of malaria in Nigeria, and under what conditions could the disease be eradicated? So the objectives of the study were to develop a mathematical model of the transmission dynamics of malaria that incorporated drug resistance, treatment, and the use of mosquito nets. Secondly, was to estimate important parameters associated with malaria dynamics in Nigeria. Thirdly, was to determine the basic reproduction number of malaria, including those for the resistant strain and the sensitive strain in Nigeria. Fourth was to simulate future dynamics of malaria, considering the treatment rates, treatment failure rates, and use of mosquito nets among infected humans with the resistant strain and the sensitive strain in Nigeria. And lastly was to identify the parameters with a large impact on the basic reproduction number of malaria in Nigeria. So the authors conducted a deterministic compartmental modeling study of malaria in Nigeria. The model involved the human population and the mosquito population. From the World Bank website, they collected data on malaria incidence in Nigeria from 2000 to 2018. Then the model was fitted to this data using the least squares fitting technique. Then they also went ahead to calculate the basic reproduction number of the model, including that for the resistant strain and the infected strain, using the next generation matrix method. In addition, using the Latin hypercube sampling method, the sensitivity analysis was done. Next, they went ahead to do simulations for the treatment rates, treatment failure, and the use of mosquito nets by individuals infected with the resistant strain and the sensitive strain. However, they had to fit the model to the data for the infected population because the data disaggregated by drug resistance status, that is by infected strain or resistant strain, was not available. So looking at the model diagram, you can see 6 compartments for the human population and 2 compartments for the mosquito population. So the susceptible human population is being populated by recruitment, moving from left to right, is being populated by recruitment either by birth, and it's also being populated by waning immunity from those who are recovered with temporary immunity. Then this susceptible human population compartment is also divided into the infected resistant and those with infected sensitive strain. Then along those lines, they go ahead to be treated for the resistant strain and also for the sensitive strain. Then they also move into the compartment for the recovered individuals, albeit temporary. Then for the mosquito compartment, we have the compartment for the susceptible mosquitoes, which is also populated by recruitment of the mosquito population followed by birth, and also the infected mosquitoes. So looking at the parameters of the model, 5 of the parameters were actually derived following the model fitting technique. And these are the ones, C, which is the reduction of infection rates due to the use of mosquito nets. Then the sigma R and the sigma S, which are the treatment rates for individuals infected with the resistant strain and also the sensitive strain respectively. And also we have the epsilon R and the epsilon S, which are the rates of treatment failure for those individuals who were infected with the resistant strain and also the sensitive strain respectively, who were treated. So the other parameters were fixed because of the model. So for the assumptions of the model, it was assumed that due to equal birth and death rates, that the total population of humans and mosquitoes are constant. And secondly, the human population was divided into 4 major compartments: the susceptible, the infected, the treated, and those with temporary immunity. However, they also went ahead to divide the infected human population into those who were infected with the resistant strain and also those who were infected with the sensitive strain. Another assumption was the model was that humans recovering from malaria have temporary immunity against reinfection. So the model also divided those who were treated into those who were also treated and who were infected with the resistant strain and also the sensitive strain. Then another assumption was that the use of mosquito nets reduced transmission by a proportion. So based on these assumptions, the model, which consisted of an 8-dimensional system of ordinary differential equations, as shown in Fig 3, was developed. So here we'll be looking at the results. Here we can see the plot of the incidence of malaria per 1,000 in Nigeria from 2000 to 2018. We can see a decline of the malaria cases over time. However, we are not yet where we want to be. The next plot on the right shows the model fit of the proportion of incidence of malaria of the data in Nigeria. So we can see that the model is a good fit of the malaria incidence. Here we are looking at the basic reproduction number as calculated using the next generation matrix method. So the parameters that were derived following the fitting estimation, and also the other existing parameters were fitted into the equation. And we have it that for malaria in Nigeria, that the basic reproduction number is 2.2364. Also, we are also seeing that the basic reproduction number for the resistant strain is 4.3561, and the basic reproduction number for the sensitive strain is 0.6454. So already we can see that the R0 for malaria in Nigeria is greater than 1. Malaria is likely endemic in Nigeria. And we're also seeing that the resistant strain is dominant, having a much more higher R0 above 1. So this plot looks at the possible long-term dynamics of malaria in Nigeria, considering the resistant strain and the sensitive strain. So the resistant strain is depicted by the red line, that's from the left. So we can see that for the resistant strain, that the incidence of malaria would range between 210 and 450 per thousand over the next 50 years, while we have a lower range for the sensitive strain, which stands at 0 to 250 per thousand over the next 50 years. Then again, we're also looking at the dynamics when plotted together. And we are seeing that generally that the malaria incidence could range from 280 to 530 per thousand over the next 50 years. So then again, simulation was also done, and we are seeing that from the plots of the effect of the treatment rates for the resistant strain, which is shown in the dashed line, and the sensitive strain, which is shown by the bold line below, we can see that even though the treatment rate was doubled, we can still see that we don't get to a case where we have no zero malaria case. So this suggests that eventually it's necessary to actually have a mix of interventions in order to achieve malaria elimination and eventual eradication. So increase in treatment failure increases the infected humans population. So from these plots, we can see that the resistant strain, which is depicted by the dashed lines above, and we can also see the dynamics of the sensitive strain. We can see that as the treatment failure rate increases, the proportion of human population who are infected also increases. Then again, we are seeing the plots of the effects of the use of mosquito nets on the dynamics of infected humans with the resistant strain on the left and the sensitive strain on the right. So we can see that with increasing use of mosquito nets, the infected human population decreases, and we are seeing more decrease among those who are infected with the sensitive strain than those who are infected with the resistant strain. Then here we are seeing the results of the sensitivity analysis for the parameters. This shows the parameters that have the highest influence on the basic reproduction number. So generally, we can see that for the infected human population, it is the parameters that are associated with the resistant strain that have higher influence on the basic reproduction number compared with the sensitive strain. So for this model now, the parameters include infection rate from humans infected with resistant strain, to mosquitoes, then the fraction of humans infected with a drug-resistant strain, the treatment rate of humans infected with the resistant strain, and also the rate of treatment failure for humans infected with the resistant strain. Then we're also seeing that the expected recovery rates of humans infected with the resistant strain is also higher. And the reduction of infection rates due to use of mosquito nets. So these were found to be higher for the, to have higher influence on the basic reproduction number when compared with the sensitive strain. So what are the takeaways from this study? We are seeing that the resistant strain of malaria is actually the dominant strain and is a major problem in the journey towards the elimination of malaria. Then, in addition, treatment failure is also a major part of the Nigerian problem of malaria. Then the use of mosquito nets could be cost-effective in reducing the number of malaria infections as well. And also considering the reproduction number that is above 1, it means that malaria is likely to remain endemic in Nigeria unless the control measures are focused on the dominant resistant strain. Then treatment failure is reduced, and also the use of mosquito nets becomes widespread. So these are the discussion questions. We can actually choose 2 or more as time permits in our breakout rooms.